So the Crud operations or creating, reading, updating and deleting elements from a Numpy array we have already covered. Hello everyone, welcome to Intellipaat's YouTube channel. In this session, we kick off the Python data structure series that consists of arrays, linked list, binary trees, searching and sorting algorithms. In the first part of this Power Pack data structure series, we will discuss the Python arrays and how to deal with them. So let's take a look at the agenda for this session. Before we begin, don't forget to subscribe and press the bell icon to get latest updates from Intellipaat. First of all, we'll start with the basic introduction to arrays, and then we will discuss the Python array module to work with arrays. Moving further, we will discuss the Crud operations on arrays using Python, and finally, we are going to sum up this session with NumPy arrays. I hope the agenda is clear to you guys. So without any further ado, let's begin. So what exactly is an array? We can consider an array to be a storage or a container that will store items of similar type. These items can be retrieved later for any computations. These elements are stored consecutively in the array and can be identified with the indexes assigned on each of the elements positioned in the array. These items can be of any data type and will follow the indexing for retrieval of the elements. Creating, adding, and removing elements from the array are the primary operations that you must familiarize yourself with. And all the other operations are built on top of these three operations only. A simple analogy to explain how arrays work is how you stack books on a shelf. Now you would want a shelf that would store all your books. So this is exactly like an array. You should be able to get the books from the shelf without searching through it all. And there has to be a system of stacking the shelves. So you can stack the books with the same numbers or with the same genre or books starting with the same alphabet, etc. But the shelf will only contain books. And now that we have a basic idea of what exactly is an array, let's see how we can implement them using Python. To implement arrays in Python, we can follow the following approaches. First is using the list, and then we have the Python array module and the Python NumPy arrays. So to understand how they will differ, let's understand the concept of homogeneous and heterogeneous arrays. So what exactly are homogeneous and heterogeneous arrays? The easiest way to differentiate between a homogeneous and a heterogeneous array is that the one that contains only single type of elements will be homogeneous and the other that can store elements with different types are known as heterogeneous arrays. The implementation of arrays with Python array module and the Python NumPy only allows homogeneous elements to be a part of them, while the list can store heterogeneous elements as well. And now that we have a basic understanding of arrays, let's move on to a few examples to understand the array implementation in Python. So first of all, we are going to start with the implementation of arrays using the Python array module. Now to start with that, we have to first import the array module using the statement import array, and the alias we are using over here is myArray. Before we start, we have to understand there are type codes available for the array module for various data types. For example, if you are using the integer data type, there's going to be another type code. For float, there is another type code, and for Unicode characters separately. Now to discuss more on this, we can go to the link available over here, which is the official documentation. Here you can see the type codes are given for C, for Python, and the minimum size in bytes is also given. So since we can see in the Python types, it's mostly integer and the float values available with the Unicode character. Number of sizes available is 2 in bytes, and for let's say integer, signed integer, we have 2, then we have float 4 bytes, and for double it is 8. First of all, we have to understand the basic operations we have to do inside an array, which is creating an array, then we have to add elements and removing the elements from an array. So starting with creating an array, we can use the Python array model which we have imported from this statement, and using the alias we are creating the array. We are providing the type codes, and inside the list over here we are mentioning the elements that we want in our array. Similarly, we have another array ARR1 and then ARR2 with separate values. One has the floating point values with the type code D, and for the Unicode characters we have the type code U. Now to check the type code, we have a method called typecode. So we can print the values using the typecode method available from the array module, and then again we can print the arrays, so which will look something like. So the first print statement is actually giving us the type codes, which is I, D and U, which we have assigned into our arrays over here, and the next values are giving the array with the type codes. Now this is not exactly how we want our elements to be accessed. So that we'll discuss later on in the session, how we access the values inside an array. But before that, There is another very important section where you have to understand how you get the length of an array. So whenever we are computing any value, let's say accessing values or removing elements, we have to understand how we access those elements. To do that, we have to make use of the indexing part, which we'll discuss just in a while. And before that, we have to understand the length of an array, because until or unless we are aware of how many elements are placed in the array or what the length of the array is, we cannot specify the range in which we want to iterate over. So iteration basically takes place for accessing the values or basically printing the array. So here we have done just that. We have used the for loop, which is in the range length of the array. Now if we already know the length of the array, for example if it's 6 or 5, we can put the range over here as 5 or 6. But for cases where we have the array in the length of thousands and 10,000s, we don't want that, so we'll just use the length method over here to get the length of the array. Now for every value inside this range, it will print the index value or whatever element is positioned at that particular index. Now we are starting from the range 0 because the index starts from 0. Now we'll discuss that just in a while. So just for example, here is how we get the values from the arrays we had just created. So when we run this code, this particular code, we are getting the values as 1, 2, 3 and so on for each of these arrays that we had already assigned. Alright, so we are getting these elements or the elements from an array from each of the arrays, array ARR1 and ARR2. So this is how we create an array and display those values using a for loop. Now we have already discussed the length of an array, and we'll discuss, so for any array that is of the length n, for example, the indexing will be the position at which each element is placed. The index elements will start from 0 and go until the end of the array minus 1. So for example, let's say we have an array over here which started from 1, 2 and 3, only has 3 elements, but the index value will be 0, 1 and 2 because the index is starting from 0 and going until the end of the array. So that is the only significant part of indexing which we have to remember, that it starts from 0. So automatically we have to understand that the entire length of the array minus 1 will be the entire indexes that we have for the array. Now coming back to how we can access the elements from an array using index values, this is how we can do that, just how we have done over here, just providing the index value whatever element we want to be displayed at. Now here we have an array which is a list in the range 1 to 100. It basically has 100 elements. Just to be a little bit clear over here, what we can do is add a step of 2 over here so that we'll have only 50 elements now. Now after this, we have created a new array with the type code I and provided the list over here which we have created just now. After this, to print the array, we are using the for loop again. So we are getting the arrays from the index value which we have iterated over from the range of length of new array. And this is how we get the array. Now let's say if I want the value which is at the index number, let's say 25 or probably at 26 or 27. So that's how we get the values. So this is a very basic example of how you can access values or elements inside an array. So now comes the part where we add the elements into an array using the Python array module. First of all, we create a new array. Inside this we have all these values and we print that array again. So this is the array 3, 4, 5, 6, 7, 8, 9 and 10. Now we want to add new elements to it. There are two approaches to this. You can use the insert method or you can use the append method. By using the insert method, you basically provide the index which you want to place your element at, the new element. And after this, the append method is basically going to append or add the value or concatenate the value at the end of the array. Now when I insert 2 and 1 at the 0 index, I get the value as 1, 2 in the beginning, which is the 0 index. And after this, if I append the value, which is 11, it's just going to add the number 11 or the element at the end of the array. Now to understand this, let's just change these values. Let's say if I want to add 15 at the end of the array, it will be 15. And instead of 2, let's say if I want to put 5 at the index number 2, or instead of 5 we put 50 over here, so the value will be 50 at the index number 2. And after that, at the 0 index we are adding again 1. So if we comment out this one, you'll see that at the index number 2 we have added the 50. So that is how you simply just add the elements into an array, and this is how easy it is. With the Python programming, it basically becomes a lot easier to deal with any data type, be it array, if it is a linked list or any other data structures that you want to talk about, Python actually makes it pretty easy to work with. Just that you have to understand how the logic works. So basically, you have to understand the addition of elements and removing of elements as well. So moving on, let's talk about how you update these elements inside an array. For example, we have this array which has 1 and 2 is actually twice in that array. So now I want to update 2 into element which is 3. First of all, we print the array. So this is the array, resulting array. And we are using the same approach, the for loop and the length of the array. After this, to update the array, basically what I have done is accessing the element at the index number, which I already know. And after this, I update this value to 3. So this is how I have just done it, assigning the new value using the assignment operator. And then when I print the array again, it is updated. Now to understand this again, instead of 3, let's say if I wanted to put 30 over here, the value will be updated with 30. And instead of this, let's say if I wanted to put it at the 5th index. So do we have a 5th index over here? Since we only have the 5 elements, we don't have the index, and it will throw us an error, which is assignment index out of range. When you are going out of the index range, it is going to throw you an index error. So that's how you know you have surpassed the index that is available to you in the array. So this is how simply you can just update the elements inside an array. After this comes the part where we delete the elements from an array. Now this is basically removing the elements from the array, and for this we can use the pop method. So now if I wanted to pop 4, let's say for example, what will happen? We are basically giving the index value number 4 over here. So instead of 4, let's give it as 2. Let's see what happens. So now we are missing one value at the index number 2, which was 2 over here. Now let's see if I do this at index number 3, what will happen. Now we have removed the element at the index number 3 as well. So this is how simply you can just delete any elements using the pop method. And since we have already covered creating an array using the Python array module, we have updated the values, we have added the elements inside the array, and we have learned about how we can delete the elements. Now comes the part where I'll tell you about slicing. What exactly is slicing? Slicing is a part of a concept which is also similar to how we use indexes. Now in the indexing, it is not just one element we can get at a time. We can get multiple elements, so that is how we use the slicing operations. Basically, let's say if I want to get, so there is an array x over here which is in the range 0 to 100, and we have taken the step as 3. We'll have probably 33 elements inside the array. Now if I wanted to, let's say, only get the first 10 elements, or if I only wanted to get from the 10th index until the 20th index from the array, so that is how we use the indexing. So inside the indexing, we use a colon over here, and after this we have the ending index and the starting index. So when I print my new array over here, which I have got from the slicing operation, you will see that this is basically how much values I'm getting, or how many values I'm actually getting. Another important concept in slicing is negative indexing, how you can use the negative indexes. So let's say if I wanted to get the starting point will be the 10th index and the ending point is minus 10, which is basically the 10th index from the end. And one more thing is, we do not really have back propagation inside the slicing operation, so we cannot go from back to let's say to the front. See, if I do it like minus 10 to minus 20, so this will throw me an error because we do not have slicing operations, or negative indexing will not back propagate. And after this we have another important slicing operation, which is basically reversing the list over here. We have used colon minus 1, and this is how simply you can just reverse the list without using the reverse method from the list. So this is all about the slicing operations we have. And if you have any questions, guys, you can mention them in the comment section below, and we'll be quick to help you out in any problems you're facing with the arrays.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job. Now let's continue with the session.
So now that we are done with slicing operations, we will also learn about how you can actually search for elements or a few searching operations using the index method. So we have a list over here which is in the range 0 to, I think this is more than 100,000, and we have a step of 2 over here. So this is a very big array or a list which we have created into an array using the Python array module, and the type code is I. So these are all integer values. Now what we have to do is, let's see, we are printing the first 10 elements of the array and we are good to go. So these are the first 10 elements of the array. So these are the first 10 elements of the array, starting from the 0 index and going until the 10th. And you will notice that one more thing I forgot to tell you guys, whenever you are giving the ending index over here, this will not be included in the result, because it will only give the values starting from the 0 index until 9. So when it comes to 10, that's where it stops and does not give you the result from over there. Now coming back to the searching operations. So we are basically searching for the index which we want. So basically, let's say this is the value we want to be searched for. We get the index from using the index method, which is we are using to search for the array. So if you already know what we are searching for, we can get the index, and using the index value, we can get the element out of the array. So this is how easy you can search for any elements using the index method in the Python array module. Now after this, I have listed down a few sorting operations as well, where we just sort the entire array into ascending values or descending values, depending upon how you want your elements to be placed at. We will basically use the list methods, which is sort, and that is going to sort our array. So we have a sorted array over here. We are using the sort method, and when we print this, so we have sorted this into a ascending order. And if you want this to be a descending order, we will just type reverse is equal to true in the sort method, and we'll get the descending order as well. So this is how easily we can perform these operations like sorting, searching, and all these adding elements, removing elements, creating the array, or updating the elements and deleting elements as well. So this is all about the Python array module that we already have. Now coming back to the session, we will discuss the Numpy arrays. So Numpy, I am sure most of you must be aware of, is a Python library, and it basically comes up with built-in modules that helps us with computations. So Python array are also one of the functions, or you can say modules, that it actually helps us with, and we can use Numpy for that. So basically, first of all, what we have to do is import array, and we are using np as the alias over here. To create an array, we use the alias np and array module, and before we were giving the type codes. Inside here, we don't have to give any type codes. It will just figure it out itself, and we're just using this list of 5 elements, 1 2 3 4 and 5, and when we print the array, this is how we get the array as. So this is as simple as creating any list, and it actually helps us with creating custom arrays as well. So here is a part where we create the array of 2 by 2, the shape 2 by 2, and which is basically all the zeros, a 2 by 2 array, and which has all the values as 0. And then we have another method once that will create a 2 by 2 array with all the values that will be 1. And you can also notice that all these values are floating point values. After this, we have a function called full, which is basically going to create whatever shape we are providing over here. Let's say if I provide the shape as 3 by 3, and we want the values of the constant that we want inside that array to be 5. So this is what we get, a 3 by 3 array with the value 5 all over as a constant. We can do this as 10, any constant value that you want to print over here. Now after this, we can also create an identity matrix, which is basically the I method. And inside this, we just provide the number like 2. This is going to provide identity matrix with a 2 by 2 shape. Then we have a 3 by 3 shape. We can just decide which kind of shape we want with our identity matrix. And identity matrix is basically a very useful concept if you are further down learning about dimensionality reduction and principal component analysis or time series forecasting. These are some of the very important machine learning concepts, and they make use of linear algebra. And in linear algebra, you'll come across identity matrix and arrays of different shapes and sizes. There you will be handling the dimensions to be, let's say, 4, 5, 5th, and that's how you want to learn linear algebra using NumPy arrays. So after this, we have another method which basically creates array with random values. So this is how you simply create it. Just give out the shape and it will create the array with random values, a 2 by 3 or a 3 by 3. Depending upon your requirement, you can just create random arrays with random values. So these are a few operations how you can create the NumPy arrays. So we have already covered how you can create the NumPy arrays. Let's take a look at how we can we have multiple dimensions that we can use with the help of NumPy arrays. So this is how you create a 0-dimensional array. Just provide the scalar value over here. It will create a 1-dimensional array like this. After this, you create a 0-dimensional array. That's how you create a 0-dimensional array. Then for a 1-dimensional array, that's how you create it. And for a 2-dimensional array, you have to create a nested list or a nested array basically. So that's how you create a 2-dimensional array. And for the 3-dimensional array, we have a 2-dimensional array nested inside a array. So basically a 3-dimensional array will consist of, let's say, for example, 2 or 3 or maybe 4 2-dimensional arrays. So now here we have another parameter called n dimensions, where we basically provide the dimensions. So if I wanted it to be a 2-dimensional array or a 3-dimensional array or a multiple dimensional array, this is how I can assign the values and get the resultant array. So now that we have covered creating the arrays using NumPy, let's take a look at how also, if you have created all these arrays, you can check how many dimensions it has using the n dimensions method. So this is how you get the values as. So the first one we are getting it as 1 dimensions, and similarly for other ones we are getting the same. For a 0-dimensional array, let's just check for the 0-dimensional array as well, if we can get the value. So we are getting that dimension as 0 again. Now moving on, let's understand the other operations that we have on NumPy arrays, just like we have done for the Python array module, like how we access the elements, how we update the elements, how we remove the elements, and so on. So reading from a NumPy array, we can use the same approach we were using for the Python array module. We're using the for loop, inside which the range is basically the length of the array, and then we print the values like this. So we're getting all these values again. Alright, so I think we have made a slight error over here. We forgot to give the indexes, and now let's see if we are getting the values again. Yes, so we are getting the similar values from the array. And that's how we read from any NumPy array, just like we have done for Python arrays. Now updating the elements again, we use the same approach. If we already know the index value, we just use the index value and update the value. If we don't have any values regarding the index, we search for the index value for that particular element, and after that we can update the value. So this is how we have done that. And now after this, to delete the element again, we can use the delete method we have from NumPy. So we don't have to use the pop method and any other methods. We can just simply provide the data we are deleting from and the index value. So since we are removing the 9th index, so we are getting the resultant array as this. So the last element has been removed. So the Crud operations, or creating, reading, updating and deleting elements from a NumPy array, we have already covered. Let's just talk about how we can search and sort from the NumPy arrays. So searching elements in any NumPy array, we are using the same approach. We have a list over here which has all these values, 20,000 values with a step of 5. So we have a sample search array we have created using the NumPy, and after this we want the NumPy where sample search array is 5500. So the difference between how we were searching the elements from the Python array module and this NumPy array, we have this where method which basically helps us give the expression which we want for our element, and we'll basically get that element. And just to check if the returning index is true or not, we will print the sample array at the index number whatever we have got from the result over here, and this is how we are getting the exact same number, which means this is basically searching the element quite efficiently. Now coming on to how we sort the elements inside the NumPy array, we are using again the sort method. which we have in the NumPy, and it is basically sorting us the element in the ascending order. Now let's see if we have the reverse is equal to true argument, if we can pass over here. So sort dispatcher got an unexpected keyword argument reverse, so we do not have that over here. So this is how we sort the elements inside a NumPy array. Now after this, let's talk about a few mathematical operations also we can perform on our NumPy arrays. So not just the Crud operations, we can also make use of mathematical operations like adding, subtracting, dividing, getting a transpose of the shape 3 by 3 matrix, and multiplying, square root. So that's how we do it. We basically have these two arrays which we have assigned using the data type integer. Now to add these two numbers, we are using the add method over here, which basically needs two parameters, just the arrays that you want to add, and we get the result like this, arrays that we want to subtract from. So this is how we can subtract two arrays. After this, we have the multiply method, which basically also has only two parameters. After this, we have the divide parameter, which has the two parameters again, which we want the number to be divided from. And after this, we have the square root. Again, the square root method will get only one parameter. So if, let's say, if I want to get the square root of all elements from an array, I can use this method. And then again, to find out the transpose of a matrix, we have created another NumPy array. So this basically is the array. Now if I want to get the transpose of this method, I'm using the transpose method with just the parameter, and this is how it will look differently. So this is the original array that we had, and this basically is the transpose of that particular array. So with this, we have come to the end of the session, guys. So that's all for Python arrays. So that's it for this session, guys. In the hands-on section, we have learned about the Python array module, how we can create an array, how we can read, update, and delete the values or the elements from the array. We have learned about how we can search the elements inside an array. We have learned about how we can sort the arrays of the Python array module. After this, we learned about the NumPy arrays, how we can create them, read, update, delete all these values from the NumPy arrays. And we have also learned about the searching and sorting of NumPy arrays. Additionally, we learn about the mathematical operations that we can perform on the NumPy arrays. So if you have any questions, guys, you can mention them in the comment section below, and we'll be happy to help you out in your journey to learn data structures starting from the NumPy arrays. Stay tuned for the upcoming sessions on Python data structures, and if you have any questions, don't forget to mention them in the comment section below, guys. We'll be happy to help you in your journey to master Python programming. Now that we are done with the session, don't forget to subscribe and press the bell icon to get the latest updates on Intellipaat.
Just a quick info, guys. If you want to make a career in software engineering, then Intellipaat provides an advanced certification program on software engineering and application development by ENICT Council of IIT Guwahati. And it is taught by IIT Guwahati professors and industry experts. This course is designed to upskill and land your dream job.